Welcome, everyone. This is part one in our series on grounded language understanding. I'm just going to give an overview. With grounding, I feel like we're really getting at the heart of what makes NLU so special for NLP, and also for artificial intelligence more broadly. So this is exciting. Let's dive in. Now, grounding is a very large topic. And so to ground it, so to speak, we're going to be focused on a particular task, which is color reference in context. I'll be saying much more about that later on. This notebook, Colors Overview, provides an overview of the data set. And that data set is the centerpiece for the homework and associated bake-off. The core reading is the paper that introduced that data set, Monroe et al. 2017. And I think that paper is noteworthy also for introducing some interesting modeling ideas that are worthy of further exploration, possibly in final projects. And I also just want to recommend a whole bunch of auxiliary readings, not required, but exciting extensions that you might make. I think grounding is a wonderful chance to do interdisciplinary work. You can connect NLP with robotics and computer vision and human language acquisition and probably lots of other topics. So I'm going to be pushing papers and data sets throughout this series of screencasts in hopes that you can pick up those ideas and run with them for your own projects. Now, to start, I thought we could just reflect a little bit on the heart of this, which is why grounding is so important and why natural language understanding is so hard. And sort of to kick that off, I've taken a slide idea from Andrew McCallum. Andrew just asks us to reflect a little bit on the 1967 Stanley Kubrick movie 2001: A Space Odyssey. In that movie, the spaceship's computer, which is called HAL, can do three things that are noteworthy. It can display computer graphics, it can play chess, and it can conduct natural open domain conversations with humans. So this is a chance to ask, how well did the filmmakers do at predicting what computers would be capable of in the actual year 2001, which is, of course, ancient history for us at this point. So let's start with graphics. On the left, you have some of the graphics that HAL is able to display in the movie, and you can see that they are extremely primitive. The filmmakers seem to have wildly underestimated just how much progress would happen in computer graphics. By 1993, which is much earlier than 2001, of course, we had the movie Jurassic Park, which had these incredible graphics for lifelike moving dinosaurs. So let's say that this is a kind of failure to imagine the future. For chess, it seems like they got the prediction just about right. So in the movie, HAL is an excellent chess player. And just a few years before the actual 2001, in 1997, Deep Blue was the first supercomputer to beat world champion chess players. What about dialogue and natural language use? So on the left here, you have a sample dialogue from the movie. Dave Bowman is the human. He says, "Open the pod bay doors, Hal." And Hal replies, "I'm sorry, Dave. I'm afraid I can't do that." "What are you talking about, Hal?" And Hal replies, "I know that you and Frank were planning to disconnect me, and I'm afraid that's something I cannot allow to happen." Very interesting. Not only is it fluent English, of course, but it's also displaying really rich reasoning about plans and goals, and it's fully grounded in what's happening in the ship. Just incredibly realistic. To give the filmmakers even a fighting chance here, let's move forward to the year 2014, which is about when Siri hit the market. And we talked about Siri earlier. Here you can see Siri doing a much more mundane version of what we just saw HAL doing, which is kind of proactively recognizing plans and goals and helping a human user solve a problem using fluent English. In this case, it's just about where to buy food, but the vision is very similar. What was life actually like in 2014, or for that matter, in the present day? Well, I also showed you this dialogue from Stephen Colbert from his show, The Pretense is that he has been playing with his phone all day and therefore has failed to produce material for the show. The cameras are on him and he's desperate, and he asks Siri for help. And you can see here that Siri does not have a deep understanding of what he's trying to achieve. I've bolded God and cameras in Stephen's utterance because you can see Siri just picks up on those as kind of keywords and says churches and camera stores. It's not even topically relevant. It's just a complete failure to recognize what he's trying to do. And then later things get even worse. Siri really doesn't understand what Stephen is saying. And so it does the standard escape valve, which is it searches the web for the speech-to-text transcription of the thing that he said in hopes that that will be helpful. A far cry from anything like a helpful, useful, human-like interaction with language. Now, why is this so difficult? I think another angle on that question is usefully brought to the fore with this analogy that Stephen Levinson offers. So he asks us to look at this Rembrandt sketch here. and just reflect on the fact that you can make out people and structures in the background, but really it's incredible that you can do any of that. So he says, we interpret this sketch instantly and effortlessly as a gathering of people before a structure, probably a gateway. The people are listening to a single declaiming figure in the center. And then he says, but all this is a miracle, for there is little detailed information in the lines or shading, such as there is. Every line is a mere suggestion. So here's the miracle. From a merest, sketchiest squiggle of lines, you and I converge to find adumbration of a coherent scene. That is indeed a visual miracle and a cognitive miracle, and it's also a glimpse into why computer vision is so challenging. To make the connection with language, Levinson continues, the problem of utterance interpretation is not dissimilar to this visual miracle. An utterance is not, as it were, a veridical model or snapshot of the scene it describes. Rather, an utterance is just as sketchy as the Rembrandt drawing. So much of what we communicate as speakers is left implicit, and so much of what listeners are able to extract from our utterances is stuff that they're able to extract only by reasoning in a general way about the context, plans and goals, world knowledge, and so forth. If our utterances were actually fully encoding in their semantics everything we intended to communicate, I think we would have talking robots at this point. But the truth is that so much of communication in natural language is left up to the context in a very general sense. And that's exactly what makes this problem so challenging. In a way, though, all of this grounding into the context and all this reasoning, if you bring it into your system, it can make things easier. It might make some intractable problems tractable. And one glimpse of that is just this topic of what linguists and philosophers call indexicality. Indexicals are phrases like I, as in I am speaking. That obviously makes reference to the speaker, and that reference is going to vary depending on who's speaking. That's a case where you can't possibly understand this statement unless you know something about who's speaking, which is a very simple kind of grounding. We1 shows this a similar kind of grounding, but it's more complicated. So now we have this phrase we, which probably by default is expected to include the speaker, but it needs to include others, and figuring out who else it includes can be difficult. And you also get more challenging uses where you say things like we, as in we, as the sports team that I follow, or something like that. So we have grounding plus a whole bunch of contextual reasoning in order to figure out what we1 would mean. I am here. Of course, I for the speaker, that's one kind of grounding, but here is an indexical expression referring to a location, and it does that in a very complicated way. When I say I am here, I could mean my office or Stanford, and I suppose all the way up to planet Earth, although that's unlikely because it's not so informative in 2021 to say I am on planet Earth. We want to go here is another use. It has we for one kind of grounding. And in this case here, if I'm pointing to a map, would be an even more complicated kind of displaced indexical reference where the map is doing some iconic duty for some actual place in the world that we are aiming to go. So another kind of complicated reasoning, but again, grounded in something about the utterance context. We went to a local bar after work. Here, the indexical is the word local, and it just shows that indexicality can sneak into other parts of speech. Local here is going to refer to things that are somehow in the immediate vicinity of the location of the utterance, and again, in a very complicated way. And then 3 days ago, tomorrow, and now are temporal indexicals, and they just show that the meaning of an utterance can vary depending on when it's spoken, and all of these expressions are kind of anchored to that time of utterance. And there are other kinds of context dependence that really require us to understand utterances in their full grounded context. Let's start with a simple example. Where are you from? This can be a vexing question when people ask, because it can often be difficult to know what their true goals and intentions are with the question. They could mean your birthplace, I would say Connecticut. They could mean your nationality, I might say the US. Affiliation, for me, that would be Stanford. And again, maybe one day it will be informative to say planet Earth if there are intergalactic meetings. That one is typically ruled out because it's not so helpful in 2021. But for the rest of them, we kind of have to guess often about what the speaker is asking of us in order to figure out how to answer. Here's some other examples. I didn't see any. That's one particular sentence. Its meaning is underspecified. In the context of the question, are there typos in my slides? I didn't see any will take on one sense. In the context, are there bookstores downtown? I didn't see any will take on a very different sense. Are there cookies in the cupboard? I didn't see any, yet again, another kind of sense. And of course, There is no end to the number of different contexts we can place this sentence in, and each one is likely to modulate the meaning of "I didn't see any" in some complicated and subtle way. We hardly reflect on this, but it's an incredible process. So just to round this out, here's an example: routine pragmatic enrichment. I've got this simple sentence in the middle here. Many students met with me yesterday. It's not a very complicated sentence cognitively or linguistically. I think we can easily understand it, but reflect for a second on just how many hooks this utterance has into the context. We need to know what the time of utterance is to understand yesterday and in turn to understand the whole sentence. We need to ask, how big is the contextually restricted domain of students here in order to figure out whether, how many is. Is it false for most students? Did I avoid saying most or all because that would be false and instead chose a weaker form many? That would be a kind of reasoning that many listeners will undergo. What's the additional contextual restriction? Is students just students in our course, students I advise, students at Stanford, students in the world? Again, the context will tell us. Who's the speaker? Of course, that's a straightforward indexical. And then there are other kinds of inferences that we might make based on the restrictive modifiers that the speaker chose. Again, we don't reflect on it, but all of this stuff is happening kind of effortlessly and automatically. This, in Levinson's terms, is the merest sketchiest squiggle of what actually gets communicated. And that is what's so hard about so many aspects of NLU. Now, I want to go back into history at least once more to Terry Winograd's system SHRDLU, because this just shows that at the start of the field of AI and natural language processing, the focus was entirely on these grounded understanding problems. So SHRDLU was a fully grounded system that parsed the user's input, mapped it to a logical form, and interpreted that logical form in a very particular world. And then it would try to take some action and generate responses. It's incredible. And I love this characterization from this YouTube clip. One project did succeed. Terry Winograd's program SHRDLU could use English intelligently, but there was a catch. The only subject you could discuss was a micro world of simulated blocks. Right? This is wonderful in the sense that it achieves the goal of grounding, but it was very far from being scalable in any sense that would make it practical. But here's a kind of sample dialogue from SHRDLU. And the thing I just want to point out is that there is so much implicit grounding into the context. The box is restricted to the domain and therefore has reference. Of course, there isn't a unique box in the universe, so the box in the general context might be very confusing, but in the blocks world, it made sense. And you can see that person leveraging that, and the computer can understand it because it too is grounded in this particular context and therefore can make use of all of that implicit information, informing its utterances and interpreting the human's utterances. And you see that pervasively throughout sample dialogues with SHRDLU. It's a compelling vision about the kinds of things that we need to have, and all of it turns on this very rich notion of grounding in the blocks world. Finally, another connection I want to make. Let's just think the very best devices in the universe, as far as we know, for acquiring natural languages are humans. What do humans do? Well, first language acquirers, children, learn language with incredible speed. That's noteworthy, just a few years. Despite relatively few inputs. I mean, they get a lot of language data in the ideal situation, but it's nothing compared to what current day language models get to see. And they use cues from contrast inherent in the forms they hear. That's a distributional idea that we're familiar with, but also social cues and assumptions about the speaker's goals. And I just feel like the very richness of this picture and its multimodal aspects are really important guiding clues for us. So what are the consequences of all this for NLU? Well, as I said, since human children are the best agents in the universe at learning language, and they depend on grounding, it seems like our systems ought to be grounded as well. Problems that are intractable without grounding are solvable with the right kinds of grounding. That's important to keep in mind. Grounded problems can seem hard, but the other aspect of that is that some problems might be completely intractable unless you have some notion of grounding. Indexicals come to mind. Thinking about current day modeling, deep learning is a flexible toolkit for reasoning about different kinds of information in a single model. You can bring in language data, image data, video data, audio data, and so forth. And therefore, it has led to conceptual improvements. The ungrounded language models of today get a lot of publicity, but there are also many exciting systems that are fluently reasoning about images and video and language together. And I think that's a really nice step forward into the world of true grounding. So we should seek out and develop data sets that include the right kind of grounding, because the central thesis here is that that can lead to progress by leaps and bounds. So again, to round this out, let me encourage you to think about this for final projects. We're going to be working with the Stanford English Colors and Context corpus. There is also a Chinese version, and we've explored exciting ideas involving monolingual Chinese and English speakers, as well as bilingual models for this data set. If you want to do a little bit more in terms of grounding, slightly more complicated context, I would recommend the One Common data set. The Edinburgh map corpus is an early task-oriented grounded corpus that could be exciting, especially if you want to do some interesting initial steps involving language and reinforcement learning. The cards corpus would be much more ambitious along those same lines. It's very open-ended, difficult, task-oriented dialogue corpus. Deal or No Deal is a forward-thinking negotiation corpus. Negotiation is a very interesting kind of slightly adversarial social grounding. Craigslist Bargain is another data set that you might use in the context of negotiation agents. And then Alfred, Crosstalk, and Room to Room are all data sets that would allow you to combine grounded language understanding with problems relating to computer vision in various ways. And again, that kind of interdisciplinary connection could be crucial to making progress on truly grounded systems.